about this. An iceberg twice the size of Greater London is on the move.
Yeah.
After like decades of being stuck.
Yeah.
This is A23A, and it's headed for this remote island called South Georgia, and it's packed with wildlife.
Oh, wow.
Today, we're going to take a deep dive into why A23A is so interesting, the potential fallout if it reaches South Georgia, and how this all ties into climate change.
Okay, cool.
And luckily, we have an expert with us who can really shed some light on all the science behind all this.
Well, this is a story that has been unfolding for almost 40 years now.
Yeah.
So let's rewind back to 1986.
1986, that's before I was even born.
Yeah.
So what happened back then?
Well, that's when A23A first broke away from Antarctica's Filchner-Ronne ice shelf.
Okay.
It's this massive expanse of ice that extends out over the ocean. And every now and then, these large chunks, they calve off, forming these icebergs.
So A23A has just been chilling out there all this time.
Well, not exactly chilling in the literal sense, but it was grounded, stuck on the seabed for over 3 decades.
Wow.
Imagine the stories it could tell.
Yeah.
It wasn't until 2020 that it started to wiggle free.
Okay.
But even then, it got trapped in these clockwise rotating currents, almost like eddies in the ocean.
Okay.
And they kept it pinned down for a few more years.
It's incredible to think about the forces at play here. Like, these currents are strong enough to hold back something that massive.
Oh, absolutely. These rotating currents, often called gyres, are driven by this complex interplay of wind patterns, the Earth's rotation,
Right.
even the shape of the ocean basins.
Wow.
It's a reminder that even something as massive as an iceberg is subject to the whims of these powerful forces.
Okay, so we have this giant iceberg stuck in a sort of watery roundabout.
Yeah.
What finally set it free?
Think about this. Over time, currents can shift.
Okay.
Their intensity can change.
Right.
And the iceberg itself can start to melt and break down,
Okay.
altering its shape and its buoyancy. It's a very delicate balance. In A23A's case, all these factors finally aligned in December 2024.
Okay.
And it broke free from the grip of that gyre.
And now it's on its way to South Georgia, right?
Yeah.
I read that the island is this haven for wildlife.
It is.
What's the worst case scenario here?
Well, South Georgia is teeming with penguins and seals, seabirds,
Right.
all sorts of incredible creatures.
Wow.
If A23A were to collide with the island or get stuck near its shores, it could block access to critical feeding grounds for these animals.
Oh, no.
We're talking about potential starvation,
Wow.
disruption of breeding cycles, even large-scale die-offs.
Okay, we have some information here about a previous incident with an iceberg called A38
Yeah.
back in 2004. I guess that gives us a glimpse of what could happen.
Yeah, A38 was another massive iceberg that also drifted towards South Georgia. It actually ended up grounding near the island.
Wow.
And the consequences were devastating for some of the penguin colonies.
Oh, no.
Countless chicks and seal pups died because their parents couldn't reach their food sources.
Wow.
A23A is even larger than A38, so
Oh,
the potential impact could be even more severe.
that's a grim picture,
Yeah,
given what happened with A38.
right.
Is there anything that can be done to prevent a similar disaster with A23A? Can we redirect it or break it up?
Unfortunately, the reality is that we have very limited options when it comes to controlling the movement of such a massive iceberg.
Okay.
Redirection attempts have been explored, but they involve enormous logistical challenges and potential unintended consequences. Breaking it up would require a tremendous amount of force, and even then,
Right.
we can't fully predict how the fragments would behave.
Yeah.
It really underscores our relative powerlessness in the face of these natural forces.
So we're left to watch and wait, hoping for the best but prepared for the worst.
Yeah.
What are the chances that A23A will actually hit South Georgia directly?
It's difficult to say for certain. Iceberg trajectories are influenced by this complex interplay of factors, currents, winds, even the shape of the iceberg itself, which can change as it melts.
Right.
It's like trying to predict the path of a leaf caught in a swirling stream.
Wow.
There are models and projections, but the reality is that A23A's path remains somewhat uncertain.
Even if it doesn't directly collide with South Georgia, are there still risks?
Absolutely.
I imagine an iceberg of that size, even just passing by, could disrupt the ecosystem, right?
Absolutely.
Huh.
Even if it doesn't make direct contact, its presence alone could have significant effects.
Yeah.
Remember, A23A is constantly melting,
Yeah.
releasing vast amounts of fresh water into the surrounding ocean.
Right.
This can alter the salinity of the water, which can disrupt marine life, particularly sensitive species like krill, which form the base of the food chain in this region.
So it's not just a collision we need to worry about, but also the ripple effects of its presence.
Exactly. And there's another potential hazard to consider.
Okay.
As A23A melts, it releases trapped sediments and nutrients that have accumulated over thousands of years.
Wow.
These can have both positive and negative effects on the ecosystem. For instance, some nutrients can fertilize the water, leading to phytoplankton blooms.
Yeah.
Which might sound good, but excessive blooms can actually deplete oxygen in the water, creating dead zones.
It's a reminder that even though it's a natural process, the sheer scale of A23A amplifies its impact and makes it a much more complex issue.
Precisely. And that brings us to a crucial point, the role of climate change in all of this.
Okay.
Because while the formation and movement of icebergs is a natural process, the frequency and intensity of these events are being significantly influenced by human activity.
That's what makes this story so compelling, right?
Yeah.
It's not just about one iceberg on a collision course with an island. It's a window into this larger, more complex story of how our planet is changing.
Right. Yeah. You know, when we think about climate change, it's easy to get caught up in the big picture. Rising temperatures, melting glaciers, extreme weather.
Right.
But this story with A23A really brings it down to a personal level, doesn't it?
Yeah.
We're talking about the lives of individual animals being directly affected by the consequences of our actions.
It's true. It's easy to feel overwhelmed by the sheer scale of climate change, but hearing about the potential impact on the penguins and seals of South Georgia,
Right.
that's what really hits home for me. It makes it real tangible.
Yeah, and that's why understanding the science is so crucial.
Okay.
It helps us connect the dots between these seemingly distant events and our everyday lives.
So let's talk about the science for a minute. How do these massive icebergs like A23A even form in the first place? I mean, it's not like a giant ice cube just magically appears, right?
Right. It's a process that unfolds over incredibly long timescales, often thousands of years.
Wow.
It all starts with snowfall in Antarctica.
Okay.
As the snow accumulates year after year, it gets compressed under its own weight, forming layers of ice. Imagine a giant layered cake. But instead of frosting and sponge, it's all ice layer upon layer.
Okay, I'm picturing this massive frozen layer cake.
Right.
But how does it end up in the ocean?
These ice layers, driven by gravity and their own immense weight, slowly flow outwards toward the coast, like an incredibly slow-moving river of ice.
Okay.
Eventually, the edges of these ice sheets extend over the ocean, forming what we call ice shelves. They're like the crust of that frozen cake floating on the water, but still attached to the main ice sheet.
And it's these ice shelves that give birth to the icebergs.
Exactly.
Right.
Over time, stresses and strains within the ice shelf, combined with factors like melting and ocean currents, can cause cracks to form and widen.
Okay.
Eventually, a large chunk will break off, often with a thunderous roar, and plunge into the sea, becoming what we call an iceberg.
It's amazing to think that something so seemingly static and solid can undergo such dramatic changes.
It is.
So we've got this newborn iceberg. Now, what determines where it goes and how long it lasts?
From that moment on, it's a journey driven by ocean currents and winds.
Okay.
It's like setting a giant icy sailboat adrift.
All right.
But instead of sails, it's at the mercy of these powerful forces.
Right.
Some icebergs melt relatively quickly in warmer waters, while others can persist for years, even decades,
Wow.
traveling vast distances across the globe.
It's incredible to think that A23A has been out there silently drifting for almost 40 years.
Right.
It's like a time capsule from another era.
It is, and that's what makes these icebergs so valuable to scientists.
Okay.
They hold within their frozen depths a wealth of information about past climates, trapped air bubbles, ancient dust particles, even the remnants of microscopic life that existed thousands of years ago.
So they're not just a threat, they're also a source of valuable scientific data.
Precisely by studying icebergs, like A23A scientists can reconstruct past atmospheric conditions,
Okay.
ocean temperatures, and even track the presence of pollutants over time.
Wow.
It's like having a frozen record of Earth's history waiting to be deciphered.
That's fascinating. I read somewhere that scientists are particularly interested in the ice cores they extract from these icebergs.
Right.
What can they learn from those?
Ice cores are like vertical timelines that capture the history of snowfall and atmosphere conditions over incredibly long periods.
Okay.
By analyzing the chemical composition of the ice layers, scientists can track changes in temperature, greenhouse gas concentrations, volcanic activity, even solar activity over millennia.
It's like having a fingerprint of the planet's climate history layer by layer.
Exactly.
So as A23A drifts and melts, it's not just water that's being released, but also this precious scientific data.
Right, and this data is becoming increasingly vital as we try to understand the complex dynamics of climate change and its potential impacts on our planet. Icebergs, like A23A, offer a unique window into the past, helping us to better predict and prepare for the future.
Okay, so we've talked about A23A's journey, the potential threat to South Georgia, the science behind iceberg formation, and their value as climate archives. But we haven't really dug into how A23A specifically is connected to climate change beyond just being an iceberg.
Right.
Can we unpack that a bit more?
Of course, A23A is not just an isolated event.
Okay.
It's a symptom of the larger changes happening in Antarctica as a result of climate change.
Right.
The rate of ice melt in the region has accelerated significantly in recent decades, driven by rising global temperatures.
So warmer temperatures are leading to more frequent and larger icebergs breaking off from Antarctica.
Precisely as warmer ocean water comes into contact with the ice shelves, it melts them from below, weakening their structure and making them more susceptible to calving events.
Right.
This process is happening all around Antarctica, not just with A23A.
That's a sobering thought, and I imagine these massive icebergs, as they melt, contribute to rising sea levels.
They do, although it's important to note that the ice shelves themselves are already floating. So their melting doesn't directly raise sea levels. However, when ice shelves break up and disintegrate, they no longer hold back the flow of glaciers from the land into the ocean. This influx of land-based ice is a major contributor to rising sea levels.
It's like a chain reaction. A23A breaking off might not directly raise sea levels, but it's a symptom of a process that is contributing to that larger problem.
Exactly, and it highlights the interconnectedness of these events.
Yeah.
What happens in Antarctica doesn't stay in Antarctica. It has global ramifications. Rising sea levels, altered ocean currents, changes in marine ecosystems. These are all interconnected consequences of climate change that are already being felt around the world.
It's a lot to take in, and it's easy to feel powerless in the face of something so big and complex. I know I often struggle with that feeling.
I think it's important to remember that even though the challenges are immense, there's hope. Scientists are working tirelessly to understand these complex systems and develop solutions. Policymakers are increasingly recognizing the urgency of addressing climate change. And individuals like you and me have a role to play as well.
What can the average person actually do to make a difference? I mean, besides reducing our own carbon footprint, which is important, but sometimes it feels like a drop in the bucket.
It's true that individual actions may seem small, but when multiplied by millions, they can have a significant impact. Making conscious choices in our daily lives, using less energy, reducing waste, supporting sustainable products and practices, these are all steps in the right direction. But beyond that, we can use our voices to advocate for change, to support policies that promote renewable energy, protect our oceans, and address climate change on a systemic level.
So it's not just about what we do as individuals, but also about how we engage with the larger systems and structures that shape our world.
Absolutely. It's about making informed choices, holding our leaders accountable, and demanding action. It's about recognizing that we're all interconnected and that the choices we make today will have ripple effects for generations to come.
It's a reminder that this is not just a scientific issue. It's a social issue, a political issue, a human issue.
Exactly. And it's an issue that requires all of us to be engaged, informed, and committed to finding solutions. We have a responsibility to protect this planet, not just for ourselves, but for all the creatures that call it home. From the penguins of South Georgia to future generations of humans.
Well said. This has been an incredibly insightful conversation, and I've learned so much about A23A icebergs in general and the complexities of climate change. But before we wrap things up, I think it's important to look ahead. What's next for A23A? What are the potential outcomes, and what can we expect to learn from its journey? Okay, so we've covered a lot of ground in our deep dive today, from the birth of A23A back in 1986 to its potential impact on this delicate ecosystem of South Georgia. We've really explored how this massive iceberg is like this floating time capsule offering scientists incredible data about our planet's past climate. But the big question looming over all of this is what happens next? What are the potential scenarios as A23A continues its journey?
Well, that's the million-dollar question. And as we've discussed, predicting the trajectory of an iceberg with absolute certainty is nearly impossible.
Right.
But let's consider some of the possibilities.
Okay.
The most dramatic, of course, would be a direct collision with South Georgia.
Right.
Given the size of A23A,
Uh-huh.
that would have immediate and devastating consequences for the wildlife there,
Yeah.
particularly the penguins and seals that rely on access to the island shores for breeding and feeding.
We've talked about A38 in 2004
Yeah.
and the devastating impact it had on some of the penguin colonies.
Yeah.
Is there any way to estimate the scale of damage if A23A were to make landfall?
It's difficult to quantify precisely,
Yeah.
but we can look to past events for some insights.
Okay.
When A38 grounded near South Georgia, it led to significant mortality among penguin chicks and seal pups because their parents simply couldn't reach them with food.
Right.
And remember, A23A is even larger than A38. So the potential for disruption is amplified.
Mm.
We could be looking at widespread breeding failures, mass starvation, a real struggle for survival for many species.
That's a grim picture. But you mentioned earlier that direct impact isn't the only concern.
Right.
Even if it doesn't collide, the presence of A23A could still have ripple effects throughout the ecosystem.
Absolutely.
Mm.
A23A is like this giant melting ice cube,
Okay.
constantly releasing vast amounts of fresh water into the surrounding ocean.
Yeah.
This disrupts that delicate balance of salinity,
Right.
which can have cascading effects on marine life.
Okay.
Krill, for instance, are these tiny crustaceans that form the base of the food web in this region,
Uh-huh.
and they're very sensitive to changes in salinity.
Okay.
If krill populations decline,
Right.
it impacts everything from fish to penguins to whales.
It's like this dominant effect where
Yeah.
one change triggers this whole chain of consequences throughout the ecosystem.
Right.
And it's not just fresh water, right? You mentioned that A23A is also releasing sediments and nutrients as it melts. Can you explain how that impacts the environment?
Think of it like this.
Okay.
Over thousands of years, as snow accumulated and formed the ice sheet, it trapped dust minerals, even microscopic life forms within its layers.
Right.
Now, as A23A melts, it's releasing these ancient particles into the modern ocean.
Wow.
Some of these nutrients can be beneficial,
Okay.
acting as a fertilizer for phytoplankton, these tiny plants that form the base of the marine food web.
Uh-huh.
But in excess, these nutrients can lead to algal blooms,
Okay.
which can deplete oxygen in the water, creating dead zones that are harmful to marine life.
So it's a complex equation with both potential benefits and risks depending on the specific types and quantities of materials released.
Exactly. And to add another layer of complexity,
Yeah.
remember that A23A is just one of many icebergs being shed from Antarctica.
Right.
As climate change accelerates the melting of ice sheets and glaciers, we're seeing a dramatic increase in the number and size of icebergs entering
Yes.
the Southern Ocean.
So even if A23A were to somehow miraculously avoid South Georgia, it's part of a much larger trend that is already reshaping the Southern Ocean
Right.
and having global consequences. It's a sobering thought.
It is. But amidst these challenges, there's also opportunity.
Okay.
The journey of A23A and the scientific research it's enabling is providing invaluable insights into how our planet is responding to climate change.
Right.
By studying ice cores extracted from A23A,
Uh-huh.
scientists are gaining a deeper understanding of past climate shifts,
Okay.
helping to refine models and predictions for the future.
It's like A23A is both a warning sign and a valuable source of information,
Right.
urging us to pay attention and to learn from its story.
Precisely, and it underscores the critical importance of continued scientific research and international collaboration to address the complex challenges posed by climate change.
So as we wrap up our deep dive into the world of A23A, I want to leave our listeners with a challenge. Don't let this be the end of your exploration. Go deeper, learn more, and most importantly, think about how you can be part of the solution. Because the story of A23A, and indeed the fate of our planet, is still being written.
Yeah, and remember, even small actions can have a ripple effect.
Right.
By making informed choices in our daily lives, supporting sustainable practices, and using our voices to advocate for change, we can collectively make a difference. The fate of A23A, and indeed the fate of our planet, is ultimately in our hands.
Well, thanks for joining us today for this deep dive into A23A and its journey.
Yeah, it's been a pleasure.